Coming up on this episode of the IoT Inc. Business Show.
Would add is a poor choice. Liability, it can be not the sensor's fault, but the designer's fault. You can make a poor choice. A poor choice might lead to, an overabundance of false positives or false alarms. And then you create alarm fatigue. And then when something important does happen, nobody pays attention.
The biggest risk a company faces when incorporating IoT into their products or deploying it into their processes is not having an airtight plan before doing so. The requirements document is the single biggest responsibility of the company and has the biggest impact on reducing risk. Dovetailing into the IoT business plan, the requirements doc provides all partners involved a clear picture of what is needed. In this episode of the IoT Inc. Business Show, we finish off costs, talk sensor security, and then discuss the risks a company faces when employing IoT into their business. This is part 2 of a 2-part interview with Scott.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on episode 5 is Dr. Scott Nelson. Besides being a baker extraordinaire, Scott is Logic PD's CTO and Executive Vice President. He brings to this conversation over 10 years of connected product experience. In the last episode, we discussed the sensor selection process and the costs involved, which is where I want to pick up from here. Now, if you haven't listened to the last episode, you should, but I don't think it's a prerequisite to this one. Scott, welcome back to part 2.
Thanks, Bruce. It's good to be here.
Yeah, I think, it was a good conversation, and I felt like there was still a lot of questions unanswered. So I just want to go back to, if you remember, we were discussing sensor selection process. One of the things you mentioned that, that I want to ask is, where do people start looking, for sensors? I don't know why I'm fixated on this sump pump example, but should someone just type in sump pump sensor, or where do they start?
Yeah. Well, I think I would probably have 2 parts to the answer. The first is, if you start on the web and if you know that, I'm building this sump pump and I'm going to focus on flow as opposed to level, for example, kind of depends on the proposition. Then yep. I know that I'm going to go look through flow sensors, or if I want to look at both and I want to look at level sensors, I can go to DigiKey. Most engineers usually start with DigiKey and they'll get to part numbers, okay. And the next day they'll have parts that they can play with. If you're a little bit less, kind of a little bit less certain of how to proceed, and you don't know, maybe because you're a pump manufacturer and you don't have any electronics engineers, you might not know who DigiKey is. Then you're going to get some help. The big distributors, Arrow, Avnet, Future, they have people that will come talk to you, and they'll bring, FAEs, field application engineers, who can very quickly not only get you on track with certain suppliers like Freescale or Honeywell that are kind of big sensor lines for them, but they also can, to be honest, and a little bit self-serving, they can forward you to people who know how to integrate sensors if you don't have the internal skills. People like Logic, we're a design partner for all the distributors. And the last thing I guess I would say, if you're kind of interested more from a almost an academic point of view, Sensors magazine, and is a really good one in my opinion. They write articles about how sensors work, which as a physicist, I'm always interested in how sensors work. That's kind of the fun part. But if you're under pressure in engineering, you're probably going right to DigiKey, Arrow, and Avnet to get going. So.
Yeah, no, those are good suggestions. Now, Arrow and Avnet and Future. What would you classify them as?
They're classic electronics distributors. They all of the various sensor manufacturers, silicon manufacturers, they all have line card membership on Arrow and Avnet's line, so you can not only get help designing those components in, but you'll be able to buy them as part of your supply chain. After you make your decisions.
And DigiKey, you're saying you start with the part numbers there. Are you implying DigiKey has part numbers for all things sensors, or is just a subset?
Well, they'll have. Yeah, I mean, if you go on to DigiKey has probably the most recognized engineering tool for finding components. They have a very, very good methodology. Our electrical engineers, it's always up on one of their screens. If they have 3 screens, one of them's a DigiKey screen, and they'll type in what they need, and immediately they'll connect you. They'll essentially connect you to the part number so that you can click on it and literally be there the next day. Nice. So DigiKey, and it's a classic catalog. They're historically a catalog electronics component supplier. Mauser's another one, but DigiKey, I think, is known better for their part finding capabilities on their website. And spec sheets are all immediate there, so that if you're trying to decide, which resolution or which sensitivity or which physical size or different things, all of that is very, very clearly, presented in their search capabilities.
Okay, no, that's helpful. And listeners, obviously, if you're in the car, don't write anything down, or walking the dog or jogging. I will put this all in the show notes, and I'll make sure Scott gives me the correct links if I don't have them myself. Okay, so and I think something else we talked about in the last episode was the difference between a sensor and an IoT sensor. We talked about the cost of the sensor. We talked about the cost of the radio, a little bit about the energy or battery potential, energy harvesting cost. What are the other, and again, we talked about a pet peeve of mine on talking about the R, the return, but not so much the I on the investment. So when we're looking at all of the I, what are some other costs involved? What are some other investments that are involved besides just finding these parts? And I presume there's going to be a little bit of cost of bolting them together. But give us a picture of that.
Well, at the front end, you have to consider, the NRE and the design problems you're going to have to do, and that's actually that's part of the make buy decision. Sometimes you'll, build. Sometimes making is going to, if you do make, you're almost for sure going to have more NRE than if you buy, and you better have more investment return than if you spend more time. And you can spend time having to design an analog front end that might be integrated by some sensor providers. The A to Ds, the communications, the radios. I mean, you can buy wireless sensors from a few people. There actually aren't as many wireless sensors available today as I would have expected. It's an emerging market, but it's not mature by any means.
And when you say wireless sensor, you mean what I've been calling IoT sensor? Then the whole package, or something
it'd be
different?
Like if I let's say that I know that I'm building a system that uses a longer range, radio of some sort, an 802.15.4 type radio protocol. Could be Z-Wave, could be Zigbee, but there are only a couple of companies, and they're actually very small and not real mature yet, where you can go and say, okay, I need a pressure sensor that has this radio, and to be honest, part of the problem is that sensors are often fairly custom. You have to have it work over a certain dynamic range and a certain accuracy, and so it's as we talked before, when you add value by integrating towards the application, if that application doesn't match almost perfectly, then you've now got something that won't work for the next application, right?
Right.
And that's why the make decision is still, fairly common, in our world, even though we're coming to the connected world. Not very many there are a lot of connected sensors, but they're not as prolific as you might expect given the amount of hype. So,
yet, I guess.
Yeah.
Right?
Then on the other side, a place where cost is sometimes unexpected is managing calibration and drift after deployment. You also have to be very careful about packaging, particularly if you're going to be outdoors, or in a lot of cases nowadays, not a lot of cases, but in some cases, if you're going implanted or you're going to be embedded, in your sump pump example, am I going to be underwater? Am I going to be in a very, tough environment over temperature? Packaging is often a key part of sensor development, and
absolutely, yeah.
And depending upon how the sensor works, if the sensor has to contact the thing that's being sensed, you got to worry about fouling, right? And you got to worry about the maintaining the integrity of the reading over the life of the product, and that can be a really high cost in some cases.
So the reading of it, or the maintenance of it, you mean, or what do you mean? What's the ongoing cost that you're referring to?
Well, you may have to implement in the system something that unfouls a sensor. You may have to create a circuit that burns back off something that gets on the sensor, or you may have to create a lot of gas and chemical sensors. They have to be replaced. They foul and have to be replaced. So when you're designing a product, you have to be thinking about, I'm designing a product where I got to replace the sensor every so often, right? And, one of my favorites was my Volkswagen Jetta, where, I had to replace that oxygen sensor, wherever it was, every 30,000 miles, the light went off, right? And I viewed that as a moneymaker, so I just found the switch that reset it, and I just kept resetting it, and But
and don't tell me you passed out that some.
No, I didn't. The car worked fine until, in fact, the speedometer died, and then I used my oxygen sensor to keep my mileage to the nearest 30,000 miles. So.
Hey, and it still worked, right?
Oh yeah, the car.
Actually, you don't know if it still worked. Maybe it was actually you were driving 40,000 miles or 20,000 miles. It may not have been replaced, right?
I didn't keep track of my gas mileage, which was probably what was suffering. But it drove, so that's what I did. So.
Okay. You touched upon packaging, the casing, and I think that leads me, I guess, to the topic of security. Let's talk security a bit. I mean, this leads me obviously to physical security. Can you talk a little bit about that, and also, I guess, other security concerns, or virtual? It would be the most obvious one, but maybe there's some others as well.
Yeah. When I first saw your question, physical and virtual, I was thinking. Well, actually, when I saw the security question, I'm thinking, well, I don't really think about security at the sensor level. I think about it more at the systems level. But then I thought about it, and I said, well, at the sensor level, I do have physical security, and I have security. We view security kind of by the motivations for security, and there are three motivations. I've classified there's kind of three motivations for security. There's assurance, privacy, and liability. And these are the things that motivate people to invest or pay for security. And then in the sensor world, I would say that the two most important motivations are assurance and liability. And so I'll talk about those two things and then come back to virtual and physical. So assurance is the idea that, I'm assured that the asset that I'm managing, or the asset that I'm protecting or measuring, is safe. I mean, and I'm assured that the process I'm running is running properly. It's all about, do I trust what my sensor is telling me? Is it accurate? Is it trending, correctly? Am I getting what I need at the right time? Lag and latency.
But do you mean it's because from a security point of view, it's potentially being tampered with, or what do you mean?
It depends on the application, but sometimes yes. I mean, we built for a company called Banner. We one time helped them build what's called a two-hand controller, and what it was there was two optical, and well, they were actually multi-sensor devices that you had to put your fingers into these two slots to make sure that your fingers weren't in the press that it was going to operate. Right? And so we had we were implementing an assurance that you're safe, right? We were implementing a safety system. And, originally we thought you first looked at the problem and you think, well, okay, I just got to make sure I properly sense the fingers. We were very quickly informed that no, you also have to worry about spoofing because they pay by piece part. So they'll put a mop handle in one device and then they'll have their finger in the other so they can get things in and out of the press faster. And so now all of a sudden, in an application where you don't expect to have to deal with tampering or spoofing, you do. And so then, that turns out to be more of a systems design issue than a packaging issue. But tampering very often can be a tampering issue. And the classic, I actually wrote down tampering. The classic tampering one is security cameras, which are a type of sensor, or proximity sensors, which are a type of sensor. And people will do things to try to make sure, if they're trying to break the security of a security system, they will try to tamper with the packaging of the sensors. So that's one. But the more often, I think the issue is my sensor, is it calibrated? Is it giving me the right information at the right time? That's an assurance issue. And then the sensor can become a liability, motivation of liability. Liability when you close a control loop, which means you take what's a closed control loop? It's basically a sensor, that is then sent to some sort of information processor, which then sends back to an actuator, typically in the proximity of the sensor. And I close the control loop. We like to say at Logic, anytime you close the loop, you own it. And so now you have liability issues with whatever it is you control. So you now have to be, as a sensor provider or as an integrator, depending upon where you are in the architecture, you may have to think about the liability of what you're sensing. And so if I'm sensing tank level, in something where an overflow will create environmental damage, then my sensor better work properly. I better make sure I have the right readings, and it's not probably unlikely that in the case of a disaster like that the sensor manufacturer could be brought in, to the fray because the sensor didn't work correctly or it didn't measure as expected or something, So in that case, you got to think about security. You got to think about it from the point of view of how does the sensor perform, and I may even have to think about it from the point of view of how safe did I package it. It's an extreme application, but it's a wide-ranging answer when you talk about security.
And so again, in both those cases, it's more you're securing the sensor so it operates properly.
Right. You basically secure the sensor to provide assurance or to provide provide proper liability insurance. So that's physical. Virtual. Yep. By virtual, I'm assuming you mean.
But before you move on, Scott. Before you move on, interesting. You didn't bring up privacy. Because snooping. It seems that's what everyone's freaked out about. I mean, and we'll go back to my boring sump pump. Although maybe there's no application here, but maybe there is. Sniffing the data. Seeing what's going on with someone's sump pump, again, probably a terrible example. Use a better one. I'm sure you have many others, but are your customers not worried about their customers' perception that their privacy, their data will be hacked? Is that not a concern?
No, well, they are. It's more about the definition of the privacy. But you're absolutely right. I mean, the sniffing of data, that was one of the things we worried about right away when I was at Honeywell and we started using Wi-Fi. The people that, if you go into a refinery with Wi-Fi, they view everything as needing to be kept secure. And of course, they don't want anybody to be able to, get in the way of a control system or even a data stream. So that's a classic privacy.
Okay.
I was gonna kind of address that in the virtual part of things.
Okay. No, that's fair.
But
that's
on the
fair.
other hand, but there's also a view of privacy that's more, and these things are a little bit, integrated, or there's an overlap, right? I mean, these different motivations, but privacy is absolutely always important to people. In some cases,
I'm just thinking someone cracks into it and hooks into it,
right.
physically, and I don't know, taps it
right.
But
it's like it's actually like what we said about the two-hand controller. So I can physically. I can physically reduce the assurance of the system with, say, the mop handle, but I could also, if it's a wireless, sensor, I could also, block or jam or do something there. So these things are not, they're not always an isolated answer, but it's a good point. Privacy for us, because we do a lot of work in healthcare and digital health, we tend to it's just our point of view. We tend to think about privacy more from a personal information point of view. It is a very important topic. The question of, if someone hacks into a control system on an oil pipeline, the question of, am I violating privacy, or am I violating, the assurance of the loop? That's that's just kind of an interpretation of syntax, I suppose you'd say. So,
okay, well, let's move to virtual then. Let's get into that.
Okay, so virtual, I'm taking, by virtual, you mean what we were just discussing, which is maybe the interception of the data stream, if it's wired or wireless. It's
potentially
getting the data. And yes, I think most of the sensors we're working on today, particularly the ones at the edge, the IoT sensors, they pretty much all assume encryption. Right? They pretty much all assume that there will be a security layer. Most of the people, like if you look at Thread, Thread, I was writing about Thread earlier today. Thread is a highly anticipated IoT, connectivity approach, and security is one of the things they talk about the most because they're targeting home automation. And whether you classify it as liability, privacy, or assurance, people in homes don't want anybody to know what anything in their house is doing, right? So, it is very important. Encryption is a common method. There are quite a few encryption protocols. Most of the security breaches that have happened thus far in what I would call this category, refrigerators or light bulbs have been hacked. They say most of them have been hacked because of people not following kind of common sense practices, to be honest. So while it is a concern, there's actually a pretty robust toolbox of solutions that work most of the time. And a lot of the final details of the security really fall on the shoulders of the system integrator, and then after that, probably the operator.
Yeah, I mean, like you said, it's pretty well defined in the IT sector or the networking sector, securing each individual layer. And, to be real, encryption, I think you're dead on. Other than encryption can be pretty darn powerful. Now, of course, other than state players, it's not going to be decipherable. So even if they do gain physical access to it and somehow tap into it, if it's encrypted, again, with the caveat of a state player, they're not going to be able to read it, right?
Yeah, that's exactly kind of the way our assumption works. That's right. And to be honest, if we don't trust it, or if a customer doesn't trust it for some reason, I don't know. Have you read the book, the Code Book? Have you read that?
No, I have not. No.
That's a book about the Enigma machine, and it's actually about the development of secure encryption over time, and it's kind of interesting. And but one of the things you quickly learn in there is that if you take any given security approach, let's say a single numeric encryption, and then you augment it with a biometric, you have a biometric measure, you significantly enhance and kind of more than redouble. It's an exponential impact on the people trying to break in. So a lot of times,
like the fingerprint on a phone.
That's right. So sometimes if you can do a couple of different security approaches and dramatically improve your level of security, depending upon the system you're deploying.
But encryption, let's just, even if you break into it, let's say, if the data's encrypted, good luck.
Yeah. Well, you still got to figure out how to use the data, particularly if you're at the far edge, right? I mean, the farther you get to the edge, typically the more raw the data, right? And so the less, the value is added as it moves through the system typically. So.
Mm-hmm. Yeah. Okay. So are there any other security concerns, just sort of wrapping up this issue?
I think the liability one of the comments I kind of would add is a poor choice. Liability, it can be not the sensor's fault, but the designer's fault. You can make a poor choice. A poor choice might lead to, an overabundance of false positives or false alarms. And then you create alarm fatigue. And then when something important does happen, nobody pays attention. And, that's not the sensor's fault, but it would be the person designing the sensor's fault. So, it's important, it's important not only it's back to the systems part, picking the right sensor for the right problem. And that's another area here in security where those types of decisions have implications.
Okay. Well, let's switch gears a little bit. Or maybe not. You have a lot of experience in deploying these sensors. What are the risks involved here? Or what are some important issues maybe that aren't known about or talked about very often?
Yeah, I think the biggest risk is just an understanding of the application. Making sure that one has an understanding of the application.
Just the system design again.
Again, and if you sub-optimize, right? I mean, if the person involved in picking the sensor, we see this once in a while. If they optimize for a particular set of requirements and they haven't taken the big picture, you can create catastrophic results because you will. Unintended consequences. That's and I thought about this risks question ahead of time. That's a big one. Making sure that I pick the appropriate technology, not necessarily the newest technology. Another thing that can happen. There's a risk sometimes, particularly in IoT. There's a cost risk. Right. Mm-hmm. If let's say I'm deploying a monitoring sensor out in a remote area where I want to keep track of something going on in a flow in an irrigation ditch or something, and let's say I either I incorrectly program my sensor or I pick the wrong sensor such that it sends alarms too often. Well, every time it sends an alarm, there's a cost impact because I'm going to communicate that through a cellular network that has costs, right? Yeah,
and there's the Chicken Little effect as well.
Well, and then on top of that, you then have the Chicken Little effect. That's exactly right. So, there are systems out there that have. It's kind of like unleashing a teenager in texting a few years ago, right? I mean, you can all of a sudden have an $800 phone bill because they didn't know that text costs per use, right? And that's something that can still happen today, particularly in remote connected systems that are going to come through usage-based cost networks.
Yeah, no, that's a good point, and I guess I have a couple questions on this. Would you consider, I guess, alerts, whether that's a phone call or a text, is that part of the sensor cost, or is that part of the connected sensor, or is that part of the system? Are we lumping that in there, or where are we putting those costs? Because you bring up a good point with these false negatives.
Yeah, well, most of the time it's going to be at the systems design level. It's going to be at properly interpreting what comes from the sensor. But if you make a poor sensor choice, if you can actually pick a sensor that is too sensitive and maybe too costly, you could have a bad situation. Most good systems engineers, if the sensor is too sensitive, they're just going to average it down, but then you're going to get to a point where, well, I've got a way more expensive sensor than I need. If I only need data once a day, I might as well get a sensor that isn't as precise and moves more, basically average it out and somehow with I can average it out with a capacitor sometimes, depending upon the bandwidth, right? So there's a risk. I think there's a risk if you don't really understand, what you need in picking the appropriate technology, that you can build in costs that you don't need, which if you spin the product, you can take it back out. But of course, particularly if you deploy and you don't find out that you've kind of overspecified till you deploy, that can be really expensive.
Well, that brings me to my next question. The second question is, who's usually involved in the company, and what are the best practices for making the sensor selection? So is it someone with domain knowledge? I mean, it seems to me that it seems like you almost have the domain knowledge, or you've got the networking knowledge.
Yeah.
Who do you see in your experiences making actually this decision, or what are the best practices? Are they getting help in making this decision? What have you seen?
So we work at Logic PD. We work as a team most of the time. So we'll have a systems engineer, electrical, and software. We'll be making decisions about the system as a team, but
with the customer.
With the customer may just give us a requirements document and say, build this, right? The customer may be involved with us, each step. The customer will always be involved, but they may say, build this for me, and then it becomes our responsibility to build it.
So is that more often than not the situation? Because that's, I'm wondering, again, for our listeners, are they just, is it best practices that they sort of just, reach out with their palms up, up facing and say, okay, you figure out my sensor, or should they be getting more involved in this? I mean, with their presumably domain knowledge, or is that just for the is that just the front end on the requirement side?
Well, it depends on the company, but I think when you get to the electronics design, typically is where the individuals that make the final decisions are, right? So most, I would say, in my experience in developing systems over 25 years, when I was developing complex electro-optic systems, with imagers, then for the most part, I was making, as a systems lead, I was making the decision. But when you get to a system where I'm building a product that has sensors embedded in it, I would say that in 95% of those cases, the electrical engineer is making the decision after the team and the systems leads define what has to be done. They'll get a set of tolerances. You have to measure this. You have to give it to me this often. I need it in this level of resolution. They essentially are given, dynamic range, sensitivity, and accuracy requirements. And the electrical engineer, in my experience, usually is the one that ends up making the decision. Some of our best signal processing engineer, the person who gets the most out of the sensors, is an electrical engineer, and I always have him, at least approve, if not make the sensor decision in anything that I'm helping to design, because not only does he understand, what the transducer, so to speak, or what the sensor does, he understands what he has to do with the signal that comes from the sensor, and you get the proper marriage at that point. But
so we're right down in there. If we back up a couple steps, even before the system requirements, I guess what we're talking about is the customer's responsibility, or the listeners to the show's responsibility, is to develop a damn good requirements document of what they want it to do, right?
Absolutely.
And that's their responsibility, more or less, is what you're saying, because there's so many other variables involved that really the end decision, and of course they'll be presented with options, I presume, and cost being a big one, cost performance, as we talked about in the last episode. But at the end of the day, the responsibility, and if someone's listening to this and saying, oh, what do I got to do? Well, what you need to do is you need to plan a very, very airtight, watertight requirements document, which of course is preceded by the business documents that we all in agreement with. Is that fair?
Absolutely. Absolutely. Okay. And included in that, by the way, will be from the marketing department, or the product management department, the overall cost of the product, because there are, as we discussed last time, there are products where the sensor might be 40% of the cost of the product. And if in that case, if they've got a $10 $10 price point, and you've got a $5 cost point, and you've got an $8 sensor in mind, that doesn't work so well, right? So
yeah. No, and I would, I think it goes. I think I interpreted the requirement document being the summation of requirements from sales, from marketing, from finance, from operations, that's what I believe should be delivered, and that's where the intellectual property. I think that's the value of the company, is developing that intellectual property or that intellect, to pass on. Like anything, like my father used to say, garbage in, garbage out. Yeah. You need to put a lot of time in figuring out the requirements. But I would say, yes, you've got the sales, you've got the marketing, you've got the operational, but it's the business component going back, repeating ourselves again, but going back to, the business, the value that you're creating and what needs to be created, which in turn drives, this requirements document.
Yeah, that's right. Yeah, we usually try to separate, to your point about the business requirements document, we put those in what's called the MRD, the market requirements document. That tends to document what do the users need and what does the business need. And then that document precipitates a product requirements document, which is typically comes from engineer and design and says, okay, this is how I'm going to meet those market requirements needs, which include the MRD has to include the price points, of course. And then the PRD has to not only address the price point, but the price point will drive a cost point because of, the various channel implications and such.
All right, Scott, I think we've got a good understanding for today. What's the future of sensors? What trends are you seeing? What are you thinking? In the networking world, we've got software-defined networks. Is that something you see, more general-purpose sensors, or not to lead you anywhere, but what do you see as the future of sensors?
Well, we talked last time, and I'll say it again. I do believe, that we're at the top of the Gartner hype cycle with IoT, but I do believe that we are going to see a massive proliferation of sensors. And the reason is because people are starting to not only understand what they can do with a lot of data, or a lot of sensors, but they're seeing value in it. And it's not surprising these days to hear that you got 50 or 75 processors managing thousands of sensors in a car, where it used to be there weren't any sensors in a car, right? 50 or 100 years ago when they started with them. So
yeah, the electronics of a car, I think for certain models can be like 40% of the cost of goods.
That's right. And so we are gonna see a massive proliferation. And and you say, okay, what types? As I said last time, I'm a solid state device physicist. So for me, it's MEMS, and more MEMS. I mean, okay. I really like MEMS.
Differentiate MEMS versus what?
Well, MEMS versus, say classic inductive, coils, MEMS versus, MEMS in some sense versus just traditional packaging, traditional pressure sensors, traditional, you take an accelerometer. I mean, in the old days, accelerometers, might have been moving bodies, now it's more about size than it is about the physics of it, but it's about how do I deploy it? How low a cost can it be? When I worked at Honeywell, we had ring laser gyros. We were starting to work on fiber gyros, and there was an idea of MEMS gyros. Today, every single one of us is carrying 2 MEMS gyros around in our pocket, right? And it's not, they're not navigating missiles into 6 foot radius areas, but they're doing a tremendous amount of valuable stuff, right? And what I'm really looking for, the next level of MEMS, and I've seen it a little bit, but I'm very excited about the next wave of electrochemical and biochemical MEMS sensors. The holy grail for diabetic care is a continuous glucometer, continuous glucose sensing. And all of the sensors they have today, they foul in 3 to 5 days. Getting to a device that can truly be implanted and operate as a sensor for the life of the patient would be ideal. But for a year would be a phenomenal improvement for diabetic care. Electrochemical, gas sensors. I mean, there's a tremendous amount of gas sensing that requires consumed, either consumed reagents or consumed, nitrocellulose fibers and so on and so forth. Getting to the electrochemical and biochemical sensors in MEMS. To me, that's a growth area, and when that happens, those types of sensors, I think, will proliferate quickly. The other thing we already talked about last time is, and you just mentioned it, really, is software integration. APIs. Getting sensors to where they are, literally almost like a software component as opposed to a physical component.
Right.
And and I think that's something that sensor people should really think about, because that means they will have added a tremendous amount of value, through the convenience, and they will have had to deal with the very difficult challenges of, what radios, what levels of signals, what dynamic ranges, all they will have to deal with all that. There are hard problems there. That's not just writing some C code or some embedded code. I mean, there's a fair amount of business work that has to be done to do that right.
Yeah. So the abstraction, I mean, and you're right. I mean, abstracting sensors, I think, is what you're saying.
Yeah, exactly. I mean, an API is essentially an abstraction of a function, right? I mean, that's essentially what it is. I mean, you get you ask me this, I will tell you this, and you don't really see on the other side how much complexity is on the other side.
It doesn't matter.
Yeah, that's right.
Yeah.
And one other, I think a good example. I was at a conference sometime in the past few weeks, and I ran into a CEO of a company called Neon Incorporated. And I asked him what he did, and he said, "I do. We deploy sensors for ecological monitoring." And I said, "Ecological? You mean like environmental?" He said, "No, ecological." And you have to think about it. But what's the difference between ecological and environmental? I mean, there's a tremendous amount of environmental monitoring, which tends to be temperature, pressure, sun, things like that. But ecological modeling is, what is the biosphere around
ecology.
What is the ecology doing in response to that? And so
interesting.
That's a whole another level of abstraction, again, to measuring measuring the next level of activity above the the physical world, right? And that's a great example. We talked about it before. I mean, it's another example, like the Whisper stethoscope, which measures lung health as opposed to just listening to sound. But that abstraction to value is maybe the way to say it. That's a trend that I think we're going to see. If the sensors people don't do it, somebody else will do it on top of their products.
The abstraction to value, huh?
Yeah.
I like it. Okay. Well, with that, Scott, we're going to wrap it up.
Okay.
I appreciate this 2-part series. Thanks, for your wisdom and sharing it with our readers. We have all your contact information, but why don't you say it again for how can people contact you and your company?
Okay. So they can kind of find us at www.logicpd.com, and they can see my thoughts and other thoughts from our company on our blog at logicpdinsights.com.
That's right, LogicPD Insights. And we'll, again, have all this information in the show notes. With that, thanks a lot, and we will be talking soon.
Okay, thank you.
Okay. That was another great talk with Scott Nelson of LogicPD, Part 2. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes one click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is From Embedded Operating Systems to Software Ecosystems with Zach Shelby of ARM. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a sensible one.
You have been listening to the IoT Inc. Business Show.